In this lesson, we're going to graph linear inequalities in two variables. We're going to graph them today when they are in slope-intercept form. All right, so what is a linear inequality? Well, let's take a look at this linear equation, y is equal to 3l over 2x plus 3. And then let's look at the linear inequality where you have y is less than or equal to 3l over 2x plus 3. And I want you to notice that in the equation that we have an equal sign, where the linear inequality has an inequality symbol, it's the y is less than or equal to 3l over 2x plus 3. So we're solving these or graphing these in slope-intercept form today. So I just want to remind you that remember the number with the variable is our slope, and then our number without the variable is the y-intercept. So notice on our graph here starts on the 3, and it's going up 3 over 2, and then we would have then taken that line to connect the dots. Where our inequality, we basically did the same thing. We had the y-intercept of 3, and then we went up 3 over 2, and then not only did we have the line, but we also had shaded below the line, and that's where we have that inequality. All right, example number 1, how do I graph linear inequalities in slope-intercept form? Well, let's go ahead and go through the steps, and then we'll go back through and I will show you how you're going to graph it. So the first step is that you need to solve for y. If we're going to graph it in slope-intercept form, you need to make sure that it's been solved for y. The second step is we're going to then take the slope and the y-intercept and we're going to plot the points. Then we're going to determine if we're going to shade up or shade down. So if we're going to determine if it's a solid line or a dashed line. And then we're going to determine if we shade up or if we shade down. So let's talk about the solid line or the dashed line. Remember when we had graphed things like x is greater than or equal to 5 or x is greater than 5? That we had said that if you have x is greater than or equal to 5, that the solution would include the 5 and everything greater than 5. So we had a solid dot, and then we shaded everything to the right. Well, when we had just x is greater than 5, it means that it does not include the 5. It's greater than 5, but does not include the 5, so we would have an open dot, but then everything going to the right. Well, the same principle happens with the solid line and the dashed line when you're actually graphing it. So a solid line would mean you would include it. So it would be the less than or equal to or the greater than or equal to. So if it has that equal sign, you're going to then have the solid line. Where the dashed line is when you'd have something just like as the less than or the greater than. And now, the shading up or the shading down, you have to make sure that you've solved for y for this to work. Y has to be by itself. But to shade up, if you had greater than or equal to, you're going to shade up. And to shade below the line would be a less than or equal to. So now let's go ahead and let's take a look then at this linear inequality. Y is greater than 2/3 x minus 4. Well, notice it's already been solved for y, so we don't have to do anything there. The next step then would be to plot the points. So we're going to identify the slope and the y-intercept. So our slope again is our number with the variable, so we have 2/3. And our y-intercept is the number without the variable, which is the -4. So on this graph, we're going to start at the y-intercept, which is -4, so we'll put our first point there. And from that point, we're going to go up 2 over 3. So go up 1, 2, and then go over 3. And so now we've got these points that have been plotted. So then our next step now is to determine if we're going to make the line a solid line or a dashed line. And take a look here. We have y is greater than 2/3. So it doesn't have the equal sign. So therefore, we need to then have a dashed line. And now we're graphing in terms of the y. Y is greater than 2/3 x minus 4. So greater than, if something is greater than, then we're going to shade going up. All right, so graph the linear inequalities using slope-intercept form. So number one, y is greater than x minus 2. So first of all, our first step is to make sure that it's been solved for y, and this one is. So let's then go on and let's graph by identifying the slope, and remember the slope is a number with the variable. So our slope is 1, and we can make that a ratio of rise all over run, so 1 all over 1. And then our y-intercept is the number without the variable, which is -2. All right, so let's plot our points. We're going to start on the -2, so on the y-intercept of -2. And then we have a slope of up 1 over 1. So now we need to determine then if our line is going to be solid or dashed. And because we have a greater than and not a greater than or equal to, we are going to have a dashed line. And because it's y is greater than, our answer or our solution is going to be everything that is shaded then above the line. All right, question number 2. We have y is less than or equal to -2x plus 3. And so this one is also solved for y. So let's identify the slope and let's identify the y-intercept. So our slope here is number with the variable, which is -2. And our y, and we can make that -2 all over 1. Our y-intercept is 3. So we're going to start on the 3. Our y-intercept is 3. And then we have a slope of -2 all over 1. So we're going to go down 2 and then +1. And now notice for this one, we have y is less than or equal to. So when you have a less than or equal to, you're going to then have a solid line because it means that it's going to be everything on the line as well. So y is less than or equal to -2x plus 3. So we have a solid line. And because then it's a less than, that means that it's going to be everything on the line and below the line. All right, so question number 3, we have -4y is greater than 12x. Well, in this case, we don't have that y all by itself. So let's divide by -4. So that cancels out. And now you have to remember from back in chapter 6, when you multiply or divide by a negative, you have to flip that inequality symbol. We just divided by a -4, so I'm going to flip my inequality sign. And then 12x divided by -4, we have -3x. All right, so now we've solved for y. So our slope here is -3, or -3 all over 1. Our y-intercept, if we don't have one, it is 0. So that means that we're going to start on the 0, and we're going to go down 3 and then +1. And now remember, we're looking at this inequality symbol right here. And it's less than, so because it doesn't have the equal sign, we know it's going to be a dashed line. And because it says less than, we're going to then shade down going below. All right, we're going to skip today and we're going to do these tomorrow. We're going to skip number 5 and we're going to skip number 6. All right, example number 3. How do I solve and graph real-world linear inequalities? You have $50 in savings at the beginning of the summer. You decide that you will save at least, and change that to $20 instead of $30, $20 a week during the summer. Write and graph an inequality that shows the possible amounts of money in your savings in terms of the number of weeks of summer vacation. All right, so now let's go ahead and let's write our equation. We're going to have the y, the amount of money that's in the account. And then before we write equals or the greater than or the less than, let's write the equation that we have. It says that we have $50 in savings at the beginning of the summer. So we're going to have our $50, and you're going to save at least $20 a week. So plus 20x, and x is going to represent the weeks. Now when we go back and we determine what our inequality symbol is, we have to then look at this at least. So let's talk about which direction at least would face. So let's say you just have to have at least $50. So the lowest amount you can have is $50, meaning you could have the $50, but then you can also have greater than the $50. So in this case, instead of it just being the 50, it's going to be at least, which is going to be greater than or equal to 50 plus 20x. So this is the number of weeks, and this is the amount of money that you're going to have in the account. That's the x, and this is the y. So it says that we have 50. Let's just number these by tens. 10, 20, 30, 40, 60, 70, and let's just go up to 80. And then we should be able to just number by ones on the bottom. All right, so let's go ahead and graph it. First of all, our slope, the number with the variable is the 20. So let's have 20 all over 1. And our y-intercept, the amount of money that was in the account at the beginning of the summer, is 50. So what that means is that you're going to start on the 50, and then every week you're going to go up 20. So you're going to go up 20 over 1, up 20 over 1. All right. And then we have to determine if our line is going to be solid or if it's going to be dashed. Well, it's going to be solid because it's greater than or equal to. And then we're going to shade going up because it's greater than. So any solution that you have that is on the line or above that line is going to be a solution to this inequality. All right, so because our lesson is getting to be a little too long, we're going to skip the second example here. In this lesson, we took a look at how to graph linear inequalities that are in slope-intercept form.